Section 7.1, Chapter 7. Here is, we want to find the square root. So let's say I have x to power of 2 is equal to 9. Now, what number to power of 2 is 9? That number obviously is 3. 3 to power of 2 is 9. So what about x to power of 2 is equal to 4? Again, what number to power of 2 is 4? Is 2. Of course, there is a negative number as well, but here we're just talking about the positive. So, because there is always positive and negative 3 to power of 2. So in that case, what I can do is here to find this 3, you could take square root of that 9. You have this function on your calculator. In this type of calculator, which is kind of fancy one, you don't really need it for this class, but you see that this radical here? That's what it is. So, like if I want to find radical 9, I'll put 9 here. It gives me that 3, okay? So, or if I want to find this 2, you just take a square root of 4. The advantage is this. Let's say I have x to power of 2 is equal to 11. Can you find a number that when you raise it to power of 2 is 11? It's not that easy to do because it's a decimal number. So what I do is I just say, I'll take a square root of 11. When I take a square root of 11, it would be, see, 3.317. It's a decimal number. Okay, so a radical, when I write something like this, like 5 and 2 and let's say 3, the number that you see here, they call this root of radical. This is root of radical, this number 2. 3 is exponent. And 5, they call it a base. Okay? Radical has different roots. You might have something like cubic root of, let's say 125, or 4th root of like 16. See, these are all roots. Now, just in case of 2, if the root is 2, normally we don't have to write that. So if you see a radical and you don't see any number here, that means root is 2. Because the only radical in the calculator here, you see there is no root. When there is no root means it's always 2. Okay? All right. So what we have is this. If you want to simplify, radical 9, let's say I don't want to use my calculator. Then you have, the root is 2, right? So you could write it if you want, but you understand if there is no number, it means root is 2. 9 is 3 to power of 2. If exponent and root of radical, if these two numbers are equal, then 3 is reduced from the radical. So radical 9 is 3. Or what is radical 25? I want to simplify radical 25. 25 is 5 to power of 2. These two are equal, so 5 is coming out of the radical. That is also true for other roots. Like here, look, 125. 125 is 5 to power of 3. 3 and 3 are the same, so 5 is coming out of the radical. Or this one, 16 is 2 to power of 4. 4 and 4 cancel, 2 is released from a radical. Also true for variables too, you know? So it's not just the numbers. Let's say I have here, I want to simplify. A to B6. I want to simplify that. We know the root is 2 and a to power of 2. B to power of 6. You know, b to power of 6, you understand, it means you got to take b and multiply it by itself 6 times. That's what B6 means. Now, can I write this as b to power of 2 times b to power of 2 times b to power of 2? Yes, because that's also B6. So here, instead of b to power of 6, you write B2, B2, and B2, correct? Now, A is coming out of the radical because 2 and 2. B is coming out of the radical because 2 and 2 are equal. Another B is coming out, and another B. Nothing left under the radical. So all these letters that have the same power as root are coming out of the radical. So what do you have now? You have A, B to power of 3, because B times B times B is A to power of AB3. Now, that's one way to do it, or you write A, and then you take the power and divide by that. So this is 2 divided by 2. You write the B, 6 divided by 2. So in that case, you have AB3. It's better to learn it this way, you know, because what if you have something like this? X to power of 12. You know, you could do it this way. 12 is 2, 2, 2, like that. And then 1 by 1 bring all these x's out. So it would be x to power of 6, right? Or just say here, write the x, write the base, and then 12 divided by 2. Take the exponent and divide by the root. So that would be x to power of 6. I think it's easier if you do it this way. Let's do this one first. Radical x to power of 24. If you don't see any number here, that means it's 2 correct. So you write it as x 24 divided by 2, or x to power of 12. What about this one? Radical 225. Find the square root of that. If I want to use the calculator, look, it's you have here, you have the radical 225 and it's 15. So you have 15. Okay. So when you do 15, you could also do it this way. Radical 225 is 15 to power of 2 and 15, okay? What if we ask you not to use the calculator and find radical 225? How does that work? All right, so in that case, you need to take 225 and break it into some factors. Anytime you want to break the number, always try to divide by 2 first. If it doesn't work, the next number is 3 and then 5. Right after 5 is probably prime numbers. All right, so I use my calculator, take 225 divided by 2. So here, 225 divided by 2. Well, it is a decimal number. I don't want that. So go to 3. Take 225 divided by 3. It gives you 75. Okay? So when you divide it by 3, it gives you 75. Then divide by 3 again. Calculator shows 25. So you have, when you divide it by 3, it gives you 25. Now 25 is not divisible by 3 anymore. You know, look, divide by 3. No, it gives you a decimal. What is the next number? Is 5. So I'll take 25 divide by 5. It gives you that. So you have something like this. Look. So when you break it, 225 is 3 times 3 times 5 times 5, which is 3 to power of 2 times 5 to power of 2. So if I have radical 225, and you know the power is 2, if you write it as 3 to power of 2, 5 to power of 2, and the 2, 3 comes out, 5 comes out. So what is 3 times 5 is 15. You could either do that, or you see that, right? You could just write, okay, 15 to power of 2, and you have 2 here, will give you 15. So it's important to understand. And normally they're saying that if you want to know whether a number is divisible by 2 or not, the first digit has to be even number. Like what? Like 20? Like 42? The first digit has to be an even number. 64, see, 4. 118, yes, because of 8. To know whether a number is divisible by 3 or not, what they're saying is add all the digits and see if the result is divisible by 3. Like what? 5 plus 2 is 7 plus 2 is 9. Is 9 divisible by 3? Yes. See, 2 plus 2 plus 5 is 9. Yes, 9 is divisible by 3. So that means that number is divisible by 3. What number is divisible by 5? If the first letter is 5 or 0. For instance, here, 40. Is 40 divisible by 5? Yes. If the first digit from the right is 0 or 5, like if I take my calculator and divide that by 5, you give me 8. Okay. Or what about 25? The first digit from the right is 5. So if you divide that by 5, it would be like this. Okay. What about 125? The first digit is 5. So when you divide it by 5, it gives you 25 and 5. Okay. All right. So now here, radical 20. Radical 20. Now we assume that you said use a calculator, but if you don't want to use a calculator, how does that work with radical 20? 20, the first number is 0. 0 also considers even in this case. But regardless of that, you remember we always take a number and divide by 2 first. And then keep doing that. So this is what you have. So you have, instead of radical 20, you write 2 times 2 times 5, which is 2 to the power of 2 times 5, okay? The only number that is coming out of the radical is this 2. 5 is staying because the power is 1, right? So it would be 2 radical 5. And this is something that we really want to discuss on 7.2, but right now, for purpose of this problem, they say, okay, use a calculator to find radical 20. They give you a decimal, 4.47. 4.472, in fact. But we need to also learn this method too for next section or so, okay? All right. So now, we go to these problems. It's find radical 3. Use the calculator to do that. Well, okay, well, if that's a calculator, let's just do whatever they are asking. 365. 19.10. And then find the cubic root. Now let's look at this one. Now, when you deal with the fractions, let's say you have something like this, square root of 4 over 9. If under the radical you have a fractions, the outcome is always a fractions. Okay, so 4 is 2 to the power of 2, and 9 is 3 to the power of 2. Now, 2 is released from the radical. When it's released from the radical, since it's already at numerator, stay at the numerator. But look at this 3. 3 is at the denominator. So when you release the 3, it has to stay at the denominator. So if you have a fraction under the radical, you end up having fraction when the fraction comes out of the radical. All right. So let's say here you have 25 here and like 16. Okay. So you write this as, and you understand if I don't put any number, it's 2, right? So we don't have to write it all the time. So you draw the fractions. 4 is coming out of the radical. 5 also is coming, but 5 is dead in the denominator. They want us to do this. 3(1) over 125. Remember, if I tell you, if I want to break a number, always divide it by 2 first, and then 3, and then 5. 125 is not divisible by 2. First of all, because the first number is not even. But let's try the calculator. It's 125 divided by 2. No, you give me a decimal number, see? And then next number to try is 3. Or you could just say, if sum of the digit is divisible by 3. 5 and 2 is 7, and 1 is 8. 8 is not divisible by, but let's just use our calculator. I want to know whether the 3 goes to 125 or not. 125 divided by 3. Nope, it gives you a decimal number. So what's the next number? Remember, always try 2, 3, and then 5. 125 divided by 5, it gives you this. 125 divided by 5 is 25. You see that? And then divide 25 by 5 again. Is another 5. So 125 is like that. 125 is 5 times 5 times 5, or is 5 to power of 3. What about the 1? If you want, you could just put a power of 3 for 1. That doesn't change anything, right? You could always put any number as an exponent for 1. What is 1 to power of 3? But still is 1, right? 1 times 1 times 1 is 1 to power of 3. So when you see 1, you could always put any number as exponent. It doesn't change anything here. All right. So now I'll put the fractions. 3 and 3, 1 is released from the radical. 5 is released from the radical. So what you have, 1 over 5. So again, remember, if you have a number at numerator, stay at the numerator. If it's a denominator, stay at denominator. How about this one? You could write it as 27 divided by 3. 3 goes to 27 9 times. How about this large number, 256? Again, to break these numbers, you always have to divide it by 2 first. So I use my calculator and do this. I'll take my calculator and divide 256 by 2. So just say 256 divided by 2. Calculator shows 128. Again, divided by 2 again, don't change anything. It gives you 64. Divide by 2 again. It gives you 32. Keep dividing by 2. 16. 8. 4 and 2. So that's how to break the number, okay? So now, how many 2's do you have here? 1, 2, 3, 4, 5, 6, 7, 8. So it's 2 to the power of 8, right? So here, 2 to the power of 8, and you have 4 here. This negative is outside of the radical. It has nothing to do with this radical, okay? So let's just leave that negative here. Now, 8 and 4. 8 divided by 4 is that, which is 4. Okay? So what number comes out is 2 to the power of 4 is coming out. Remember, don't bring the negative inside. One thing before we go further, let me say something about this one here. You know, I see a student, when they see something like that, they're not sure if this is -4 or is +4. Remember, if there is a negative, if there is a parenthesis around a negative number, then it means this 2 means you're taking -2 and multiply by -2, which is +4. But if there is no parenthesis around this, means this negative has nothing to do with this part. So it's -4, right? See, it's like something like this. I have -9 plus 12. What is -9 plus 12? It's +3, right? Can I write this 9 as 3 to the power of 2? Yes, 3 to the power of 2. See, this negative is not really affecting this part. Okay? So it's -9 plus 12. But when you have something like that, do not write it as -3 parentheses around +12. Why not? Because this means +9. It doesn't mean -9. So the only time that you actually write it positive when there is a parenthesis around the negative number and raise it to the power of 2 or even number. Okay? So that's why here, when you reach to this part, this is 4, and you have a negative stay there. How do I simplify 5th root of -3125? So that means I need to break these numbers. Okay? Is it divisible by 2? (3125) divided by 2. No. Is it divisible by 3? No. Is it divisible by 5? Yeah. Oops, sorry. 3125 divided by 5. Yes, it's 625. Yes, it's 625. Divided by 5 again. Yeah, it's 125. Divided by 5 again. It's 25, and divided by 5 again is 5. Okay? So how many 5 are there in 3,125? 5 to the power of 5. And how do I know it's divisible? If I don't want to use my calculator, how do I know it's divisible by 5? Remember, if the first digit from the right is 0 or 5, that means the number is divisible by 5. Okay, so now here you write this as -5 to the power of 5. Why? Because if you take -5 and multiply by itself 5 times, Then you have negative 125. Cancel. Negative 5 is coming out of the radical. If the root is odd number, if the root of the radical is odd number, it's okay to have a negative number underneath of it. If the root is odd, it's okay to have a negative number. What about this one? Hmm. 81, let's break 81. 81 divide by 2 doesn't divide by 3. What is 81 divided by 3? It's 27. Divide by 3 again. Divide by 3 again is this. Okay? It's 3 to the power of 4. Can I write this as negative 3 to the power of 4? No. Why not? Because negative 3, if you multiply by itself 4 times, the outcome is positive 81, not negative 81. Let's just use our calculator. Is it right? 4 root of minus 81? No, calculator would give you undefined or error. Let's think of the simple example. Look, use your calculator and just try to find a square root of minus 9. Calculator would give you error. If the root is even number, you cannot have negative on the direct negative number, okay? And the calculator would tell you that. If the root is odd, is okay, but not the even. If the root is even, why calculator give you the error? Because you cannot have the negative number if the root is even. And we prove it to you. Can we write it like this? No, because if you put a parenthesis around negative 3 and multiply by itself 4 times, it doesn't give you minus 81. But that's not the case here. Look, if I put parentheses around negative 5 and raise it to power of 5, that give you minus 125. See? I mean minus 3125. So it would be okay. So this is something you need to remember. How do I simplify that one? Okay. 30 divided by 5 is 6. I want to simplify that. Well, I need to break 729. Let's try divided by 729 divided by 2. It doesn't work. Okay, but let's divide it by 3. Always 2 first, then 3, then 5. 729 divided by 3, 243. Divide by 3 again. 81 divided by 3 again. 27. 9 and 3. Okay. So I have 1, 2, 3, 4, 5, 6 is 3 to power of 6. So here I put 3 to power of 6, 42. Now, one by one, you write the base first. 6 divided by 6, you write the base, x. 42 divided by 60. Both of them are released from the radical, nothing left under the radical. So it would be 3x 7, because 6 goes to 42, 7. Now, 256. I gotta break that number. Let's start with divide by 2. 256 divided by 2. Yes. 2 goes to 56. Hey, give me 128. Divide by 2 again. 64 divided by 2. 32 divided by 2. 16. Keep dividing. 8. 4, and finally 2. Okay, so how many 2s are there here? 1, 2, 3, 4, 5, 6, 7, 8. 2 to power of 8. So 256 is 2 to power of 8. So then would it bring 2 out? X 2 to power of 4, 2, x to power of 4, or 4x 4. So it's okay to have a negative number under the radical. Why? Because root is odd. If root is odd number, you cannot, I mean, it's okay to have a negative number. So what do you have? Just negative 5. Okay? 13 divided by 13. I want to simplify that. 8 is what? Divided by 2 is 4, divided by 2. 8 is this. 2 times 2 times 2. So it's 2 to power of 3. X to power of 9. Okay, this 2 comes out of the radical. X also comes out of the radical. So it's 2x to power of 3 simplify 16, A 10, B 36. Again, when you don't see any number, it's always 2, right? Okay. But what about 16? Isn't 16 right here? What if I have 16? Then isn't that 2 times 8? Okay, so 16 is 2 to power of 4. All right, so start one by one. 2 to power of 4 divided by 2, A to power of 10 divided by 2, B to power of 36 divided by 2. A2, I mean 2 to power of 2, A to power of 5, B to power of 2 goes to 36, 18. And just write it as 4, A 5, B 18. $28 divided by 4. This is B12, sorry. Okay. 4 goes to 28, 7. 4 goes to 12, 3. You want to simplify this one? $81 divided by 2 doesn't go to it, right? So divided by 3. We did this before, so I'll just show you again. 81. Again, remember, always divide by 2 first. If it doesn't go, divide. So 81 divided by 3, it gives you 27. Okay? And then 27 divided by 3 give you 9 and so on. So 81 is it's 27, and then that is is 3 to power of 4. 25 is 5 to power of 2. Remember, if there is a fractions under the radical, again, when you bring a number, if the number is at the numerator, stay at the numerator. If it's at the denominator, stay at the denominator. So this 3, you write that as 3, 4 divided by 2. 5, 2 divided by 2. Okay, 5 is stay at the denominator. You see that? You just transfer it like that here. So it would be 3 to power of 2, 5, or 9 over 5. 27 is 3 to the power of 3, x to the power of 9. Okay. One by one. Z6, it comes out, is at the numerator, you write it as that. 3 to the power of 3 is at the denominator. So you take all the power and divide by exponent, see? Three goes to 6, 2. 3 and 3 cancel. X, 3. So remember, always you take the exponent, divide by root. Exponent, divide by root. Exponent, which is 9, divided by root, which is 3. There is one problem here, it's kind of completely different, you know, not that easy. So I'll save it almost to the end of this subject here. How would I do that one? There is a, how do I come up with x2 plus 2x plus 1? You know, it's just, when we were doing factoring, we were saying that here you open two parentheses, you put x and x, you find two numbers, when you multiply is 1, and when you add is 2. So that would be x plus 1 to the power of 2, okay? So here you put x plus 1 to the power of 2. And then x plus 1 is coming out of the radical, right? But since we don't know what the value of x is, it always has to put a sign of absolute value outside of it, because we don't know whether x is positive or negative, you know? So that problem is a little bit different. So just try to remember. The reason we have absolute value, because we don't know if x is positive or negative here, you know? So the outcome always has to be positive. All right. Now, what's the problems? So this function is given. G of x is cubic root of x minus 54. You have this. They're saying find g of negative 10. Okay. Now, before I continue with this problem, let's just go a little bit over this part. You know, when we give a problem like this, y equal, another example, y equal x plus 1. When we say x is 3, find the y, how do you find the y? Don't you just list 3 and substitute here, and you just say, okay, y is 3 plus 1 is 4, and then you put a 4 here? Or when we say, okay, what about x equals 5? How do you find the y value? You take that and you substitute here for the x, and then you just say y is 6, right? What if I say instead of y, I say f of x is x plus 1? F of x and y are the same thing, right? F of x is x plus 1, and find f of 3. F of 3 means what? F of 3 means substitute 3 for x and find the y value. Both means the same thing, okay? Y and f of x are the same thing. So when I say f of 3 means if x is 3, what's the value of y? So why don't you just go ahead and substitute? So sometimes why we are using f of x and g, because if I have another equations like 2x plus 5, okay? I don't want to use f of x because I already use f here. I'll use another word like g of x. It's just to show you that there is another functions instead of letter f. It could be any letter. You could say h of x equal to 2x plus 5, okay? So all it means is just a different functions. But what you need to understand is this. When we say, like here, f of 3 means take 3 and substitute for x. Or here, let's say I have h of x, right? h of x equal to this. I say, what is h of 1? What does h of 1 means? If x is 1, find the y value. So you take this 1 and substitute here. So you just say 2 times 1 plus 5 is 7. Okay? So here, what is g of negative 10? Means take the negative 10 and substitute here. So then I have cubic root of negative 10, negative 54 is negative 64. Is that okay to have a negative number under the radical? Yes, because why? Because the root is odd. The root is odd number. You're allowed to have it. Because 64, you write it as minus 4 parentheses around to power of 3. See, if you take negative 4 and multiply by itself 3 times, you get minus 64. And then negative 4 is released from the radical. The last subject of 7.1 is talking about the domain and range, mainly domain. And range always follow that. What does that mean? Let's have this equation, y equal x plus 5, okay? Now, you know, for you to plot equations, you always need some points. Can I substitute 0 for x? Yes, because when you put 0 here, 0 plus 5 is 5. Can I put a positive numbers like 2? Yes, 2 plus 5 is 7. Can you use the negative number like negative 7? Yes, negative 7 plus 5 is negative. See, you're allowed to use any number. It doesn't matter whether it's a 0, positive, or any number. When you substitute, you always have a value for y. In this case, we say domain is all real numbers. You know what domain is? Domain is the x. X is the domain. And range always follow the domain. Okay? Domain is all real numbers. It means you're allowed to put any number for x and you always come up with a y value. So range follow that too. Range is all real numbers. And when you graph it, not a nice pictures here, but let's say y is 5 here, 2 and 7. See, the graph goes all the way to infinity, positive infinity, negative infinity, whether it's going to the y or to the, so all real number continue all the way to infinity because you're allowed to put any numbers, okay? Now let's look at these equations here. Okay, can we put any number for x? Does 0 work? Yes, because then you have, what is radical 0? Well, I use my calculator if you're not sure, okay? What is radical 0? 0, oh, okay. So there is a 0. So yeah, 0 give you a number, that's okay. It's okay to put 0. What about like 25? Radical 25 is 5. 5 minus 5 is 0. Yes, you have a value for, okay. What about a negative number like minus 4? Does that work? No, you cannot have a negative number when the root is 2. How do I know? You want to find radical negative 4, right? Anytime you want to put negative, just use this one. See that? Negative 4. So you want to calculate like, look, error. Okay? Why? Because when you have a negative, when you have an even root, you cannot have negative numbers. So here, you allow to put any numbers except the negative. Okay? You cannot have, x cannot be less than 0. On the number line, if this is 0 and all the negative here, you cannot have the negative number. So if that's the case, you just say domain is all positive number, including 0, but not the negative one. Now let's look at this one here. It said identify the domain. Which one of this graph it goes beyond the x? It goes toward the negative x. See? This one shows that it goes through the negative x. You don't want that. And what else? And what you could do is you could always identify a couple of points. For instance, you see how this one has, at this point, y is 0. This point is y is 0, right? So let's say here y is 0. See what happened when y is 0. I'm sorry, when x is 0, what is the y value? Negative 5. Okay, this point, you see that? This point, x is 0 and y is negative 5. Which is D. This is the answer, which is this. The other one, they don't have any numbers below. What if you have a functions like that, f of x or y equal cubic root of x minus 3? What about that one then? Yeah, when the root is 3, is odd, you could have any number, okay? It doesn't matter whether it's a positive or negative. Look, x equals 0, cubic root of 0 is negative 3. X equal negative 8. What is cubic root of negative 8 minus 3? It's negative 2, is negative 5. See, in case of odd numbers, you could have positive or negative. So domain is all numbers. Domain is x, right? Domain is all real numbers. It means your graph can go both sides on positive x's or negative x's. So here, in this problems here, they just tell you which one is correct. they say goes all the way, domain is always positive, negative, positive, infinite, negative. That means you can take any positive or negative numbers. It doesn't matter. Okay, that's why this one, see? See, this two doesn't go all the way to, how do I know which one of these two? This one, it has the graph above. So like when X is 10, it shows that Y there is a value, right? Let's see if that's true or not. What is cubic root of 10 minus 3? So let's just try that. This is a calculator that doesn't have that one. Well, let's say if this is cubic root of 10, it gives you a value. Let's say it's like 3 to power of 3, which is 27, or 3 to power of 2.5 or 2.9. So that give you, the outcome give you a negative number. So that means when you have a negative for Y value, the Y value falls below this one. In this sophisticated calculator, see what happens. So anyway, so I need to figure that out for you with that particular calculator. So that end of section 7.1.